Hey everybody. All right, and today we are going to go into how to make a really basic mechanical or engineering drawing of a part in Fusion 360. Now, a little bit of a disclaimer. I do not claim to be an expert in GDT, which stands for geometric dimensioning and tolerancing. Now, there are a lot of rules when it comes to making a mechanical drawing. And there's a lot of specificity, and there's probably a lot of stuff that I am just not going to cover. This is meant as an introductory lesson into what the purpose of a mechanical drawing is and how to make a really basic one and how to use the tools. All right. So, in our project right now, we are working on reverse engineering. We are modeling a product in Fusion exactly as we see it, and then we are eventually going to model a part that will serve as some sort of improvement, and we'll 3D print that improvement and we'll put it on the real life object. So, for example, if I wanted this to have a pencil holder for whatever reason, I would model a holder that fit this radius and it could hold a pencil. That's an example of an improvement. All right. But one of the requirements is once you model all your pieces, you give them textures, we are going to make mechanical drawings of them. Now, the purpose of a mechanical drawing is if someone wanted to make this piece here, so this is the cap, right? This is this piece right here for the spray bottle. This is the cap. If someone wanted to make this product, manufacture it, how could they do that? What information would they need to know in order to manufacture this product? Okay, so the first step for making a mechanical drawing is we're going to click up here where it says design, and we're going to go to drawing and then drawing from design. It'll bring up this little dialog box. Under sheet size, I usually choose A just because that is standard printer paper, so we can print it out on my printer if we need to. And then we press OK. And it'll take a second to load this up, but essentially we should get a mechanical drawing here. So here's our dialog box, and it will automatically want to place a view, which we can go ahead and do. Now, you can either have a mechanical drawing with multiple views or you can have it with one view. It really depends on how complex your piece is. Something with a lot of parts and something with a lot of measurements should probably get its own dedicated sheet. Whereas something simple like this, we could probably fit two views on it to express everything that we need to know. So first things first, this is obviously quite small. Our scale is currently 1:1. So this is a piece of printer paper. This is how big our cap is. Now, we're going to inflate it a little bit because we want to be able to see the whole thing. So I'm going to change scale from 1:1 to 2:1. And this still looks a little small, so let's try 3:1. All right, that looks a little bit better. That's a little more clear. The other thing is we don't want the hidden line style. We want the visible edges style. So I'm going to select that. And then I'm just going to click to place my view and then press OK. All right. So we've got our front view here. Now, the only other view we are going to need is the side view, which I should be able to use the project view button here to get our side view right there. If that doesn't work for whatever reason, because your rotation is messed up, you can just do base view and then change the orientation of your object. But if you use the project button, it'll preserve scale, which is good because down here it says scale 3:1, which we want to stay consistent. Okay. All right. First things first. Anything circular needs a center mark. We need to denote where the center is for this object. So up here under geometry, there is an option for a center mark. And these two circles share the same center. So I can click on either one of these and it'll generate a center mark for that. And that's good. All right, now what else do I need to know? In order to make this part, I need to know this inner diameter, this outer diameter, and then I need to know the depth of this part here. One thing we want to avoid is what's called redundancy. Redundancy is effectively making the same measurement twice on one sheet. So for example, an example of redundancy is if I wanted to take my dimension tool, I'm going to label my inner diameter, I'll label my outer diameter, And then if I wanted to label the height of this object, I could do that here, but you'll see that this measurement is the same as this measurement. And that's because they are the same. That this is the outer diameter of my object, which is the same thing as this one. That's an example of redundancy. I don't need both of these measurements here. So I'm going to get rid of this one. So I have my inner diameter, I have my outer diameter. Now all I need is the depth of the part. So I can click dimension, and then I can click this part, and that's how I can get my depth. Now, that is basically all of the information that someone making this part would need to be able to know. Now, you could dive much deeper into something called tolerancing, which is essentially when you go to manufacture a product, it is impossible to get this measurement exactly right. Usually you'll be off by 0.001 or 0.0001 or something like that. And that's called tolerancing. And generally there's like an acceptable range that this can go from. So it might say 0.63 and then plus or minus 0.01. That might be our tolerance, meaning that it would be acceptable if this was 0.64 or 0.62. Those would both fall within the acceptable category. But then if it was 0.65, that would fall outside the category, and then this part would be rejected during quality assurance once it's manufactured. But we're not going to dive into that right now. We're just going to do general diagramming and dimensioning. Okay. The other thing I want you to change is this title block stuff. This is auto-generated based on the name of the file and the project you're currently in. And even though my organization system makes sense to me, on a sheet, it doesn't really make sense. So if you want to change this, you can just go ahead and double click this. And then I can click on this, and I'm going to call this reverse engineering project. And then this title looks bad, so I'm going to call this spray cap. And then it says it was drawn by me on this date. It's at a scale of 3:1, and it's sheet 1 out of 1. So if you end up having a part that is very complicated and you need multiple sheets to represent multiple views, you can label sheet 1 out of 1, sheet 1 out of 2, sheet 1 out of 3, depending on what you're trying to do. Okay? And then the revision number, you can get this from the part. So under my spray cap, it says V1, or right here, it says V1, because I only designed this once and I didn't make any edits from there. But let's see, this bottle I revised once, so that's version 2. So if you look at your version number over here, that's the revision that you can make if you wanted to. So, and that's pretty much it. There's other stuff in here where if we were engineers working in the field, there would be other people checking this stuff. We would have some sort of organization system, some drawing numbers, just to keep everything nice and consistent. But that is the basics of making a mechanical drawing. So just keep in mind, everything circular needs a center mark. Your dimension tool is your best friend. And then if you want to type something, you can always double click on these measurements. So let's say you have a couple holes that all share the same diameter. You can type stuff here. So let's say there were like 2 holes that both had this diameter and there were 2 of them. Rather than dimensioning both of them, I can just dimension one of them and then put x2 after that measurement. And that would serve as saying that there were 2 of them. All right. So again, I am not an expert in GDT, and there's a lot more rules behind this, but this is just a very general overview for how this stuff works. All right, and that's it.